So as we defined earlier, kinetic energy is a useful form of energy that we associate with objects due to their motion. In order to quantify the kinetic energy of an object in motion, we can use this formula. The kinetic energy of an object is 1/2 multiplied by the mass of that object in kilograms, multiplied by the square of its speed or velocity. In most cases, we'll be looking at objects that are only traveling in one direction, and therefore the speed of that object is equivalent to its velocity, or the magnitude should be. It's important to note that, again, if you want to get energy in terms of joules here, you need to be using a kilogram for mass and meters per second for your units of speed or velocity. We will derive this equation in a later video, but for now, know that you can use this equation to quantify the kinetic energy of any object in motion. I would like to ask you to pay special attention to the fact that kinetic energy is directly proportional to the mass of an object and directly proportional to the velocity squared. Okay, now this part's very important, right? So which one, mass or velocity, has a greater effect on the kinetic energy, right? If I double the mass and I double the velocity separately, how would that change the kinetic energy, right? So if I were to use times 2 of the mass, right, I would get times 2 of the amount of kinetic energy because it's proportional to m to the power of 1. And so therefore it's just whatever happens to the mass will happen to the kinetic energy. But because the velocity is squared, if I multiply the velocity by 2, I will actually get, right, 2 squared. I'll get times 4 amount of kinetic energy. So if you double the velocity, you get 4 times as much kinetic energy. If you triple the velocity, you would get 9 times as much kinetic energy. If you quadruple the velocity, you would get 16 times as much kinetic energy. So even though it includes both mass and velocity, kinetic energy is more greatly dependent on the speed or velocity of an object. So please do not forget to square this when you are doing calculations by hand. Let's take a look at a quick example in one of my favorite animals, the cheetah. The cheetah is considered to be the world's fastest land animal, achieving a maximum speed of 64 miles per hour. Let's calculate the kinetic energy a cheetah has at this speed if it has a mass of 49 kilograms. To quantify the kinetic energy of the cheetah, I will once again bring out our kinetic energy formula. And I see that in order to quantify the kinetic energy, I need both the mass and the speed or velocity. I am given both of those things. However, I do want to report my answer in terms of joules, and I see that my unit for speed is in miles per hour, and my mass is in kilograms. Okay, this one's fine. Kilograms is good, but miles per hour needs to become meters per second. So what I'm going to do first is turn 64 miles in 1 hour into meters per second using dimensional analysis. Take a moment, pause the video, and see if you can do this yourself before proceeding. All right, so I've gone ahead and began to cancel out the time into get seconds. So when the hours will cancel now, hour goes away, minutes cancel, and now I have miles per second. If I stop right here, I'll get miles per second. Let's keep it going a little bit. I know that in 1 mile, there are 1,609 meters. Okay. Then from here, I'm done. I now have meters per second. Okay, so this ends up being roughly 28.6 meters per second. That is the top speed for the cheetah. So now I have my mass and my velocity in the appropriate units. I can just go ahead and plug into my formula. 1/2 times 49 times 28.6 squared, very important, and that will be equal to 20,046 joules of kinetic energy, or I can report this using scientific notation if I would like to. That's also equal to 2 times 10 to the power of 1, 2, 3, 4, right? It's 4 decimal places over, 10 to the power of 4 joules, and we can just round to the nearest 1 here, so 2 times 10 to the power of 4 joules. And that is how much kinetic energy the cheetah has there. Just a quick units check, just to make sure this works out. Kilogram was the unit of mass here. And then I did meters per second, squared that, right? So that was the unit for speed, and we squared it. So that would be a kilogram times a meter squared over a second squared And that is what a joule is in base SI units. So we're good. That works out. This is actually a very useful tool to help make sure that you've squared the speed appropriately. If you forget to square the speed and you check your units, you will be able to see that you do not get the units for a joule. So I would recommend checking your units when solving problems like this.